This week we'll turn the lights on with the 5 new components in the Rhino tab's render section. After watching this video, you will know how each of these light types work, what kind of settings you should use with them, and what kind of behavior you should expect from them. Let's cover these with examples. Here is today's setup. In the middle you can see a peek of the Rhino's light tab. If you don't see this panel, you can right click on the edge and add it. On the left side we have the Grasshopper script. I have 2 sets of light components, one for each viewport, and a content cache that I will push the lights into. I'm going to change the viewports to match the script and turn the skylight on. This is going to be our starting point. Now, as discussed in the previous video, you know that the rendered and the ray traced mode look a bit different, and I wanted to show them side by side for comparison. Let's zoom into the ray traced part of the script. Here we have our directional light, linear light, point light, rectangular light and spotlight components. We'll cover these one by one. These components share most of their inputs and outputs. They all have color intensity and shadow intensity inputs. Color changes the color of the light, and intensity and shadow intensity are for balancing the brightness or the emitting power of the light and the contrast between light and dark. All of the components also have the enabled input to toggle the light on and off. Let's start with the directional light. How this component works is that you have a location and a vector that defines the direction of the light. So in this view, the light comes from the top left and goes towards the bottom right, according to the arrow displayed on the model. You can see the intensity and fall off settings that I'm using on the viewports. Let's move on to the linear light. This is supposed to represent a tubular light bulb, so it needs a line input. As you can see in the rendered mode, it really doesn't represent a line at all. And in the ray traced mode, it doesn't work at all. I'm not sure if this is something to do with my setup or if the component is just bugged. Here I have linear lights that I have created manually in Rhino. Now you can see in the ray traced mode how it is supposed to look. And in the rendered mode, even the manually created line light doesn't work. I have tried this with different fall off functions, but it doesn't help at all. As a reminder, you have 3 types of fall off functions: constant, linear and inverse squared. The inverse squared is the most appropriate from physics perspective. The linear is what the name says, and constant just uses the same value across the whole surface. I discussed this more in the last video. You can check that out after this one. I will put a link to it in the end screen. Okay, let's move on to the point light. This works just how you might expect. You simply provide a point for the location input, and that's where the light will emit from. Moving on to the rectangular light. Much like the linear light, this also doesn't work how you would expect in the rendered view. In the ray traced mode, this works properly, so you will give it a plane and a rectangle. I have used a point in the plane input because that's what you do in Rhino when you want a XY plane, and I have inputted a number slider to adjust the size of the rectangle. Moving on to the spotlight. This one works reasonably well both in the rendered view and the ray traced mode. For the spotlight you need to input a starting location and a target location. So your light cone will start from the location input point and it will be directed towards the target input point. Kind of like the directional light. Now the difference between the spotlight and the directional light is that the directional light comes from an infinite distance away from your model and touches everything. The spotlight will start from a location that you have defined and it will be directed towards a target. You will also adjust the spotlight angle, which means how far the light cone will spread instead of coming in an unidirectional way. We can demonstrate how the spotlight works by moving the target point. spotlight angle can narrow the light, and the spotlight hardness will change how crisp the edge of the light will be. There's quite a bit of hassle with the lights and the different render engines, so if your lights don't work, I suggest you adjust the fall-off settings and the intensity, but if these don't work, the light component is probably broken. My computer has been working hard to provide you the ray-traced previews, so I hope you enjoyed the video, and if you did, give it a like and subscribe to the channel. That is all for now.